A very good morning to you all and welcome back to Dr. Vipin's Biotech and Bioinformatics classroom. So we had discussed dplyr in an earlier lecture. This was lecture number R_18, data analysis with dplyr. And in this lecture, we had discussed some of the verbs that are used with dplyr for data manipulation and data wrangling. So we will have a very brief introduction of those verbs. And then today we specifically talk about the join function, which is another important utility with dplyr, which can allow you to join two data frames together. So dplyr, as you know, is a powerful R package to manipulate, clean and summarize unstructured data. And this process is known as data wrangling. And I'm sure by now you know how to install a library, but just to give you a piece of advice, so you could do the installation using the command line. So you could use the command install.packages, and then in round brackets and within double quotes, you write the library name, which in this case happens to be dplyr, right? Again, installation is a one-time process. Once you're done with it, you don't have to install again and again. But whenever you want to use a library in your program, you have to invoke it or call it into the program. And the command for doing that is you give the keyword library and in round brackets, the library name. In this case, again, this is dplyr, right? And I'm sure you would also remember from the previous lecture that we discussed about the dplyr verbs, and we discussed about several such verbs like select, filter, arrange, mutate, group by, and summarize. So join basically is used to combine two data frames together based on a certain criteria. And depending on what criteria you use, there are several of join functions that we're going to discuss today. So as I said, join basically is to join two data frames together. So you must have two data frames in hand to use join. So here in this case, I show you two data frames. The first data frame is named data1. The second data frame is named data2, right? And in data1, again, you have a header tag, and then you have the values in X. So the tag has A and B, and the values in X are 1 and 2. Likewise, in data2, you have a tag B and C, and the values for tag B and C are 3 and 4. So there are several ways in which these two data frames can be joined together, one of which is to combine them completely. And wherever there is a common tag, you give the value. If there is a tag exclusive to one and not in the other, then of course, wherever the value is missing, you write an NA. So this is what is known as full join. And when you fully join these two data frames together, this is what you get. Basically, you have three tags, A, B, and C. And whenever there is a missing value, you put an NA. For example, in this case, for tag A, there is no value in Y because there is no tag A in Y. So therefore, you have an NA here. Likewise, for tag C, there is no value in X, so therefore you have an NA here. So this is what is known as full join, where you combine the two data sets together or two data frames together into a single data frame, and the missing values are basically replaced by NA. So likewise, there are other functions in join that allow you to selectively combine the two data frames together. For example, you have what is known as inner join. Inner join allows you to combine in the two data frames, combine the values that have a common tag. For example, here in this case, the only common tag that you have between data1 and data2 is B. So when you say inner join and data1 and data2, what you get is just B with the values of X and Y corresponding to B. Right? Then you also have the left join and the right join. So the idea of left join is that the tags from dataset 1 will be your tags of reference, and all corresponding values in dataset 1 and dataset 2 will be joined together. So in this case, when you say left join data 1 and data 2, what you get is this. So here you are, tags from the data 1 are your reference. So you have two tags, A and B, and corresponding values in X and Y are joined together. And in case there is no corresponding value in dataset 2 for a given tag, then in that case, you get an NA value. So for example, here in this case, there is no tag A in dataset 2. So therefore, the value for tag A in dataset 2 or Y is NA. Likewise, you also have a right join. And as is understood, in the right join, the dataset 2 tags become your reference, and corresponding values in dataset 1 and dataset 2 are combined together. And again, in case there is no corresponding value to a tag in dataset 1, the value is replaced by NA. So this is your right join. And in this case, again, you have the tags for dataset 2, BC. C is not found in dataset 1. So therefore, in that case, you have an NA value here. Otherwise, the corresponding values are given. Then you have what is known as semi-join. As the name indicates, it gives you half the data, not the complete data. And what is the data that you get? It is basically the... So all tags in dataset 1 that are common also in dataset 2 will be shown for dataset 1. So for example, here when you say semi-join data 1 and data 2, what we get is B and 2, because B is a tag that is common to data 1 and data 2, and the value of B in data 1 is 2. And likewise, you also have anti-join. So when you say anti-join data 1 and data 2, it gives you the data for data 1, which is not found in data 2. For example, here in this case, A is exclusive to data 1. So you'll have A and its value X in the data set now. So now we have completed the basic commands in join. We'll now go for a practical demonstration, and probably you'll understand even better now. So here you are, you have two data sets, data 1 and data 2. You have a tag header, which has some common tags and some different tags in both the data sets. And these tag headers are used to combine the values of data set 1 and data set 2 together. So you have a full join, which will combine the two data frames together completely, and all missing values will be labeled as NA. Then you have inner join, which will give you the common tag between the two data sets and combine their values together. Then you have the left join, where the reference data set is data set 1, and the tag in data set 1 and the corresponding values in data set 1 and data set 2 are reported together, and missing values are labeled as NA. Likewise, you have the right join, where dataset 2 becomes the reference. So tags in dataset 2 are a reference, and the corresponding values in dataset 1 and dataset 2 are given together, and missing values are labeled as NA again. Then you have semi-join. Semi-join is basically where your dataset 1 is a reference, and you're looking at what is common between dataset 1 and dataset 2, and only the value in dataset 1 is reported. And likewise, you also have anti-join. Again, you compare dataset 1 and dataset 2. You look for a tag that is exclusive to dataset 1, and only dataset 1 values for the corresponding tags are reported. Right. So let's now get into the practical demonstration and see how this works out. So here we are in our studio, and we start by creating the two data frames. And then, of course, we use the join function to join them in various ways, depending on our requirements. So we start with creating the data frame 1, and first, we define two vectors. So you have a vector called tag, and we say tag equals to concatenate or combine the values of A and B into a single vector, right? That is what we're saying here. I'm sure you remember C is for concatenation. Likewise, you use X, and then you say X equals to concatenate 1 and 2 together. So now you have two vectors in hand, the tag vector and the X vector. And now we put them together into a single data frame using the command data.frame, right? So we say data.frame, and then as an argument to data.frame, we give the vector names tag and X. So we say data frame 1 equals to data.frame, which is the key command for creating a data frame, and the arguments to data.frame are tag vector and X vector, right? And you have your first data frame. This is data frame 1. You have two columns here. The first column is tag. The second column is X. The tag column has character values A and B, while the X column has numeric values 1 and 2. Then we come to creating the second data frame. And again, we create two vectors and combine them together into a data frame. That is data frame 2. So here you are, you say tag equals to combined B and C. Likewise, you say y equals to concatenate or combine 3 and 4, and then you say data frame 2 equals to data.frame, and as an argument to data.frame, you give the values of the vectors tag and y here, right? So here you are. This is your data frame 2 now, right? So if you see very clearly, there is one tag that is common to data frame 1 and data frame 2, that is B. There is one tag each, which is exclusive to the two data frames. It is A is exclusive to data frame 1. Likewise, C is exclusive to data frame 2. So B is common to both, while A and C are exclusive to data frame 1 and data frame 2, respectively. Now you need to also invoke the library that you want to use for the program. So because we want to use the join function of dplyr, we need to invoke or call into the program the dplyr library. In my case, the library is already installed, so I'm not installing it again. In your case, if you are running dplyr for the first time, dplyr does not come with base R and it has to be installed. So I've already shown you the command line method of installing it. You can say install.packages and then in round brackets and double quotes, the library name dplyr. Or else you could use the R Studio integrated development environment to install. So you come here to packages, and in packages you go to install, and in install you can select the library that you want to install. So in this case here you say dplyr, and then of course that prompts you also. So you can select this and click on install. All right, so next we move on and we talk more about how to use the join function to combine the two data frames together. So here we are, the first of the functions that we're going to use is to what is known as the full join, right? So the first what we use is full join. Full join, as the name indicates, it is going to combine the two data frames together completely. And our column by which we are combining the two data frames is the tag. So this tag has to be a column that has to be common to both the data frames. So we give a variable name data3 equals to full underscore join. That's the key command of join that we're using here. And then, of course, first you have to give the two data frames that you want to join. So you give data frame 1, comma data frame 2. And then you say by equals to. So this is basically defining the column through which you're trying to join the two data frames together. And you say by equals to tag, right? In double inverted commas. And then, of course, I print data frame 1 and data frame 2 first so that we have a reference of the values that we had in these data frames. And then we also look at what is the actual values in data frame 3 and their spatial arrangement. So here we are. This is our data frame 1. This is our data frame 2 for our reference. And this is the new data frame that we have created by combining the two data frames together. And very clearly, if you see for tag A, the Y does not have any value. So therefore, you have it NA here. Likewise, for tag C, X does not have a value. So therefore, you have a NA here. And rest of the values are faithfully copied. So this is your full join. This is the simplest of the join commands. Here you're simply combining the two data sets together into a single data frame using one of the columns as your reference, right? And in this case, the column for reference is tag. All right, so then we move on and we talk of what is known as the inner join. So inner join is a function that basically combines rows with common tags into a single data frame. So let's do this here. So you say data underscore 4 equals to inner underscore join. And then again, you give the two data frames that we want to join together, data frame 1, comma data frame 2. And then again, by, which is the column that we're taking as a reference to combine together. So by equals to tag. So what this is doing is it is going to look for the tag columns in both the data frames and pull out the common tags and print their values for X and Y. So here we are. This is your data frame 1. This is your data frame 2 again. And then this is the final combined data frame with inner join. So inner join is going to pull out the tags that are common between the two data frames and their corresponding values. So here in this case, there is a B tag that is common. The value of B in X is 2 and in Y is 3. So now we move on to the next command and we come to left join and right join. So we first talk of left join. So you already know now that data frame 1 has two tags A and B, while data frame 2 has tags B and C. So therefore, what would happen is in this case that you're looking at the values of data of tags A and B in data frame 1 and data frame 2, and the missing values are replaced by NA. So here is how you go about it. You say data 5 equals to, so data 5 equals to left underscore join, data frame 1, again, data frame 2, and by equals to tag. So let's run this here. This is your data frame 1. This is your data frame 2. And what you get as data 5 is the tags in data frame 1 and its corresponding values in X and Y. So you get a value of 1 and 2 for data frame 1, and you get a value of NA and 3 for data frame 2. And this is your data 5, and very clearly the tags in data frame 1 are being used as reference, and corresponding values in data frame 1 and data frame 2 are printed here. Since data frame 2 does not have an A tag, so therefore the value for Y in data frame 2 is shown as NA. So now we move on to the right join. Right join is very similar to left join, except that in the right join, the reference tags will be taken from data frame 2. So in this case now, your reference tags will be B and C, and values of X and Y will be joined together into a new data frame. So here you are, you say data 6 equals to right underscore join. And again, in round brackets, data frame 1, data frame 2, by equals to tag again, right? So let's run this here and see. So here are our reference tags. Reference tags are B and C because this is right join. And then again, because there is no C tag in data frame 1, you have an NA value for X here, right? So this is what is your left and right join. I'm sure intuitively you understand that you could easily mimic the function of the right join by altering the order of data frames in the left join, right? So now we come to the next join command, and that is what is known as semi-join. So as the name indicates, it is only going to give you the partial data and coming from one of the two data frames. So what this does is to use data frame 1 as a reference and print the common tag and its value in data frame 1, right? So the comparison is between the two data frames, and whatever is tag is common, that value for data frame 1 is printed here. So here you are, you say data 7 equals to semi underscore join, and then in round brackets, data frame 1, comma data frame 2. So data frame 1 becomes a reference, and you are again looking at the tag column here. So you say by equals to tag. So tags in data frame 1, which are also common in data frame 2, and the value that is printed is only for data frame 1. So that is why it is called the semi-join. So here you are, you say data 7 equals to semi underscore join, and in round brackets, argument 1, data frame 1, comma, data frame 2 by equals to tag. And so when you run this now, here you are. So you get again your data frame 1. Likewise, data frame 2, you have the tag of B and C, and you have the values of 3 and 4. And then, of course, you have data 7. So data 7 basically consists of tags common between data frame 1 and data frame 2, which is in this case happens to be only B, and then only the value in data frame 1. So you have B tag and X value of 2 coming up here. So this is basically your semi-join or partial data coming from data frame 1, keeping in reference data frame 2 as well, and pointing out what is common between data frame 1 and data frame 2, but printing the values only for data frame 1, right? Now we move on to the final join function. This is known as anti-join, and as the name indicates, basically you're looking at, again, data frame 1 as your reference, and looking at value that is exclusive to data frame 1, not found in data frame 2, and printing only the value in data frame 1, right? So here you are, data 9 equals to anti underscore join, data frame 1, data frame 2, by equals to tag. And then again, you print the two data frames for a reference, and finally print your data 9, which includes the anti-join values for data frame 1 and data frame 2 when they're searched with respect to the tag, right? So here you are, you run this now. So when you run this now, here, this is what you get. Tag A and X value of 1, right? So this is what you have with respect to join function. Now you might be wondering, why do you need the join function? So many a times you would have your analysis where you would have some output of, let's say, a gene set, and you would then want to associate this gene set to the annotation that it has, and your annotations may be in a different file. So again, you'll use your join function, you will search the annotation data frame with respect to the gene name tag, and then of course you can combine the two values together to get your differentially expressed genes with the annotation and their actual function, right? There are many examples where you would want to combine two data frames together, and you might be looking for the commonality, you might be looking for the exclusivity of one versus the other, or second versus the first one. So that is where the join functionality comes in. I hope you have understood. And of course, we meet again very soon. And next, we talk about how to read a FASTQ file in R. Until then, keep watching Dr. Vipin's Batek and Bioinformatics Classroom. There is a whole lot of functionality now into this. We are very close to putting the 100th video in this channel. And then, of course, again, a humble request, if you like the content here, please do click the like button. Also, recommend to your friends through WhatsApp group. That is the best way to spread. Also recommend it to your friends and your lab mates, your juniors, your seniors, your university colleagues, so that we very quickly reach good numbers, right? Thank you very much, and I see you again in the next video.